Hello everyone, this is Mohammed from Python in the YouTube channel, and today we will learn together attribute override in object-oriented programming. Class attribute overriding is associated with the constructor which is init in the term of a class in Python. To utilize the attribute overriding, the inheritance must be exist because we override the attributes from the parent class in the child class. In another word, if we have a class, a parent class with some attributes like age, name, salary, and we want to inherit this class attributes to another class, okay? And at the same time, in the child class, we want to add our own attributes, like another new attributes doesn't, these attributes don't exist in the parent class, but we want to add this to child class. There are, or the aim of the attribute overriding is to make our child class have its own constructor or own attributes, not just the attributes from the parent class. This is the main idea behind the attribute overriding, is to have new attributes at the child class together with the parent attribute. We can override the class attribute by using this statement, okay? So in the child class, in this line, which we will use to define the constructor of the child class, we have or we must include all parent attributes, okay, and the new attribute, okay. So the constructor of the child class will comprise all parent and the new attributes. And in the second line, we will use super, okay. So there is a super method. This super method will be inserted in the second line directly after defining the constructor and storing its attributes. And this super is a method, okay, a class. So it's nothing but a method that allow us to access the attributes in the parent class. Now this will be more clear. So we need a child class with a constructor, and under the constructor we need super method. This super method will allow the child class to connect to the parent class, okay? And inside the child class we only define or store the new attribute. There is no need to store the parent's attribute because it's already stored in the parent class. Remember, the override can be applied at the instance attribute level, and also we can override the method itself. So there are two types of overriding. We can override the attributes, or we can override the method itself. Okay, now let us start programming and coding our class. So as usual, we have now a class, for example, for Amazon, okay, engineering department, and this Amazon has its own constructor, and in the constructor I will have the name, I will have the age, I will have the salary, okay, nothing other than the these three attributes. Sorry, caps lock is working, okay. And we want now to store self.name. We want to store the name value in the attribute self.name, and we want to store the age value in self.age, and lastly we want to store self.salary or salary, and we want to store the value of salary in the self.salary. And let us make like not just a naive class, we want to add our method, but I will not use the method in this description, but just to add some flowers to this class, and this will return to me nothing but a string saying that the name, okay, that we will insert is able to write to. Okay, now this is like a naive or vanilla class for Amazon like object, okay, for Amazon engineering, like the department or whatever is, there are three attributes for the instance that we will make: the name, the age, and the salary. This is like the normal class we usually build, okay. Now, how can I like override these attributes, okay, and add another attributes and a new child class? Then we will build another class as the first rule or the first condition that the inheritance should be exist to override these attributes in any child class. So let us build the child class. I will have a class here inside Amazon department. I will have another department, for example, for Python developers, okay. As the first rule, we need inheritance to be able to override the attributes. Then we will inherit the Amazon engineering department, okay, inside this Python development. The second condition is to have a constructor. How can we have constructor? We will define our own init, okay. What should exit inside this constructor, okay? The first thing, we want to list all attributes from the parent class, okay? Let us add name, add age, add salary, okay? Then, after finishing adding all attributes from the parent class, we want to add the attributes that we want to add to the child class. So I want to add a grade. So grade is not located inside the parent class, and it's located inside the child class. This is the main idea behind attribute override. And in the second line, okay, we want to use directly the super method. Then I press enter here, and please take care about the indent or the space. We want to be in this zone, and we want to use what is called super. Super is nothing but a method. So what you can do here is, after entering here, you just write super, okay, and this super will contain two things. The first thing will please consider that this could be automatically added, or you want to add it by hand, okay. So let us repeat it again, and I will have super here, just either to be filled automatically. What inside the super will be? Inside the super, you will insert the name of that child class, the class that you are working with now, and then we need self, okay. Also, self is required, as I said, that because self allow the instance to access its own attributes from outside. When I make an instance, I need self to access the attributes and methods. But super itself allows me to access the attributes or the access, the method inside the class of another method, okay? Not when I make the an instance, okay? So super is different than the self, because of super allow me to access the parent class method. So we said that this is a special method. Super allow me to access it, okay? And inside this, so I use super, okay, here to access the init. And what will be inside this init? Inside this init will be only these attributes. Don't store the grade or the new attribute inside this constructor, because this constructor is the constructor of the parent class. The only thing that you need to do is to store self.grade in the grade, is to store the value of the grade in the self.grade. Again, we have our own parent class, and we build a new child class, and inheritance is exit to make the override. Now, the second line is to have the constructor that comprises all attributes from the parent class and then a new attribute. Okay, then the first step, I need to call super. What is super? Is a method, okay, allows me to what? Allows me to access the constructor of the parent class. So I connected the constructor, okay, and now I have here inside this constructor the main attribute or the attributes in the constructor of the parent class, and in a new line I do only store the grade attribute that is inserted, okay, for the Python development class. Remember that if you remove this from the super, the same method will work because these are default arguments, okay, but let us keep them. And now the last thing what we can do is to make an instance. So I have p1 for example, and this is an instance from Python development, and I want to insert, for example, let us do the keyword argument, for example, name equal Mohammed, okay, and I want to use the age, okay, and I want to use salary, okay, let us use any random salary, and I want to use the grade, okay, senior, okay, sorry, senior, this will be in the keyword argument. So remember, go back to function to remember what I mean of keyword arguments. When we recall arguments inside the function or inside an instance and use its name, the original name, this is called keyword argument, but I can remove them if they are a positional argument. If I run this, I have no problem, then I can access, for example, the name of this py1.name. For example, I can access the name, I can access the grade, okay, so there is no problem. Okay, now this is the procedure to make a class attribute override, in which we do inheritance of the parent class inside the child class and add our own attributes as grade. Here it's not located inside the parent class, and we can do later our own functionality, but there is a procedure to do that. The first thing, inheritance should exit. The second thing, the constructor of the parent, if the child class, should contain all its attributes, okay, from the parent class and the new one. Then in the third line, we need self method to be able to access the constructor. So remember the difference between super and self. In self, okay, why I need self here and here? We mentioned that many times. Self is a method that allow me, okay, or its attribute, the self method, allow me to access, okay, the instance, okay, so I can access the instance attributes. For example, I can access the instance attribute from outside, and I can access, okay, for example, inside the class. So this is based on the class. It's not allow me to connect the class with the class, but super allowed me to connect method from a class to method of another class, okay, and allow me also for the self, allow me to access the attribute. For example, I can say self.name equal, for example, Ali, okay. Now self allow me to go to the attribute, okay, inside the instance itself at the instance level, meaning that anything after the constructor can be accessed using self, and I can access the class level methods, okay, from outside when I use self, okay, as a gateway to access the attribute. Now we have our own attributes here. We have the original attributes, but what if I want to make it more professional? Okay, if I want to make it more professional, then instead of using or listing all name like this, okay, we can change the attributes, okay. Instead of listing all attributes here, what if I want to use, for example, the arbitrary arguments, in which, for example, I want to use, for example, args, okay, here. So remember that we can add a new argument in the front, then we can use add, and instead of listing this, I can also use arg, okay, and remember these should be all removed. We use only positional arguments, okay, so no need to use this attribute arguments, okay, so no need to use this keyword, okay, and we can run. Then we have the same result. So what we did here, we use the keyword args, okay, and the keyword args mean that go and list all positional arguments from the parent class, and here I use the keyword args. And remember, if you shift this args before the grade, okay, then you will have a problem because you must list all positional argument, okay, before the keyword argument. Here we have a grade, okay, and we now have the ability to use the keyword argument. Now I can also, instead of using arg, I can use instead of using arg, I can use quarks, which is keyword arguments, okay, quarks, okay, and I can use here quarks, or what name is, okay, like this. And in this case, I can remove this also to be in the last, okay, that's a grade, just to have the, oh sorry, we have to list this in the beginning because of the positional argument, and I must say, for example, the grade at the beginning here, okay, for example here we have senior, okay, then all arguments after the grade will be keyword arguments. And now I will insert the name is equal to 100, okay, and I will insert the age will equal to this quantity, and salary will equal to this quantity, and I can run the program. So we also learned now another level of professional coding. Instead of listing these attributes, I can use here the attribute, the keyword arguments, okay, which is come from the arbitrary form, meaning that when we describe the arbitrary argument, we said that if I use args or quarks, okay, with the star, then we term it as arbitrary arguments. Remember the position of the new attribute, unless you will use, for example, grade equal none, okay, and this even should be at the beginning, okay. So you have to take care where to place the quarks or args, okay. And yeah, see you next tutorial.